Hello, I'm Livia, and we want to introduce you to our submission for the BGI sprint, in which we try to use predictive coding for a real case usage scenario such as glucose prediction. How we did that? Well, our project Glucose DAO already tried a model with transformers to predict basically glucose values into the future. For that, we use data from a sensor from CGM, which is basically a time series. Every 5 minutes, it has a glucose value and some occasional covariates such as insulin and carbs. For this specific test in the sprint, we used a simplified dataset that does not contain covariates. It's only a time series, and it's like smaller in size than the one we used to train our model. We kind of had a time constraint of 2 actual working days for the project. So unfortunately, we didn't have time to train to the end or to reach the values we've managed to reach in the transformer architecture, for which we had months of fine-tuning. We tried to get, however, the best results. And because we had this predictive coding, we tried to test multiple architecture and to use Optuna for hyperparameter tuning. In the case of the architectures that you can, well, see here in this document, you will be able to find in our repo and, well, pull request. You can actually see that we have 4 models. The baseline is literally the FabricPC implementation of transformers with predictive coding, as is. For the others, we tried to add hope field because we were advised that it might help in improving basically results. And we tried to run the hyperparameter optimization to see actually how it will get. You have all the hyperparameters we used in the list here. It has to be brought to attention the gradient part, the gradient clip, where basically we had noticed that there is numeric instability in the model. So gradient clip kind of prevents the numeric instability from from spreading. Other things that we've noticed is that hyperparameter tuning does help mitigate variations of the predictive coding. That's why you do have, in this case, specific hyperparameters such as hope field strength or variance. Variance sending whichever architecture we use, and well, hope field strength it uses, but also classical hyperparameters such as depth, sequence length, and learning rate. So these are classical versions basically. What you need to know besides these generic parts is you have the results of the study here. What was the conclusion? Well, unfortunately, hope field did not improve as much as we would have expected. And in case of just predictive coding, mind you, it's just 2 days of runs, we didn't achieve the same MAE as we've achieved with the classical transformer architecture. So in our case, it was 12 something. Here, I think best was 19. And for each of our runs, you have a detailed, well, view in which you have the hyperparameters that we've read, which was the best configuration, and probably more important, or more simply understood, are the graphs. In the case of the graphs, you might need to pay attention to the color coding. This orange yellow is basically the pruned version. So basically when the model trains and it has no more space for improvement, or the improvement is too small, that's why it's pruned, and the complete version which ran to the end. There will also be some red ones, which are the failed ones. I think it will be seen later. What is to be found, you can actually explore it either by leaderboard or by a trial in particular you've seen here, and If you want to go to details, you have details. Here you have to check out the later ones where we have more information on the graphs. I'm scrolling a bit because, as you can see, there are kind of lots of results. Here are the next colors, like I said, the red being the failed one. And look, you have it also here. And they're specified. You might actually find some who are still saying like running. Running is, at least in our test, runs that have not completed. Even prune had the closure. Not completed means we kind of had some technical issues because we have been running it on two devices, one being also a laptop, which kind of had electrical issues, and or they were too long. Because look, in case of Hopfield, we only got, in this case, only 2 runs that were okay, and in later runs, like here, we had that numeric instability we mentioned previously. As you can see, here we have an average of 20 for mile, let's say. The green one is 600 something, while the orange yellow one is almost 1000. So it's like 5 times, well, 50 times, sorry, the value. So this kind of numeric instability, and let's see, 15 and 21 in all trials, 15 and 21, here is 15. You can actually see that it went with this variant, which does include Hopfield. So it is not very stable, unfortunately, but this is specific for our use case, and it was not developed in depth due to lack of time. This actually requires more study. What you get at the end is a review per validation, the validation of learning curve, and you can see the fluctuations and the commands. What are the key takes away from here? Well, in this case, we can say the following. First of all, per our use case, Hopfield was not very helpful, and from the point of view of time, it was very intensive. So few Hopfield runs were longer than actually just the predictive coding. So predictive coding was definitely faster. Another point is that you have those numeric instabilities that were mitigated indeed by the gradient hyperparameter we've integrated. And other mentions would be more, well, practical, more direct, like on what you run it. The main part from which the pull request is made is out of Linux system. I tried running it on Windows, and the only way to properly run it is under VSL. And I mention this because we made this nice output, we hope, with explanations, so that more people can actually interact with a real use case and find a way to apply them for whatever they have. And the pull request, where you can actually see everything, it's here. You can actually find it on GitHub, or like just check the fork that was made. And I think actually that's all. We hope we explained everything clearly.